Okay, now let's talk about the builder design pattern. So here, as the name suggests, it's sort of a way of creating or rather constructing objects step by step, right? Like adding optional components and configurations, and again as the previous ones with respect uh, uh, with respect of creation of design patterns, here also you want to separate the construction process from the representation of the object. And so let's see how we can create complex objects by adding components to it when we go to the demo. But first of all, let's see how to do this. Mainly you have to have a director class that orchestrates the construction process. He's sort of like the manager or the conductor. So he's sort of making that he sort of defines what goes where, right? And then you have to create the builder, which is an interface with methods for building various parts of the objects. As our previous demonstrations, interface is only a set of rules to how to do this, right? And then we have to implement this builder interface in a concrete builder classes to build the different types of objects, right? Depending on the class that we are implementing, we can alter the behavior or come up with our own implementation to the methods provided in the builder interface. Then only after at the end of all of these things, we are providing a method to retrieve the constructed object, right? So it is sort of a separating the construction of complex object from its representation, allowing same construction process to create different representations. So process is the same because we are using an interface. Interface has defined process on how to do this with different methods. But depending on the concrete class that we need to implement, we are changing the behavior, or rather, not the behavior, we are changing the representation of the created object. So now imagine a custom burger. Now, if you go to Subway or somewhere, you know that you can decide what sort of a bun you want and a patty and toppings and other sauces like tomato or things like that you can define, and they will create a custom bun or a burger for you, right? So let's look at the implementation of this code. Now here you can see we have a burger class. A burger class has a set of properties. As per my implementation, I have a bun, and then I have patty, then I have toppings, then I have condiments, which are sort of spices, salt, pepper, things like that. Sorry. And when we want to display this, we are writing the console to what is the type of bun and what is the type of patty and what are the toppings, right? And what are the spices that we have used to create this burger. Okay, so now this is the builder interface. So burger interface, builder interface has a set of methods, or rather it is mainly the way of making a bun. We have to set what type of bun, then type of patty, then the toppings, then the condiments or the spices. Then we'll, at the end of all, I mean, doing all these things, we are returning it. We are calling the returning method as the build method. But you can do whatever you want there. Uh, so in the build method, we are trying to return the things that we have done in these earlier steps, which is the iBurger build. Now let's create a uh, class called Deluxe Burger Builder. So this is a type of some sort of a premium burger, right? Now it is a concrete class, it is not an interface. If you want to create a deluxe burger builder, how you're going to do it, right? So you have to first of all implement this iBurger builder and follow these steps, right? So let's try to do that. And we'll first of all implement iBurger builder here. And then in the set bun, we are setting some sort of a sesame seed bun, right? Which is a bit expensive, right? And then in the patty, we are making it a beef patty, right? Um, so let's next implement the set toppings method. Here we'll set toppings as lettuce, tomato, onion, and pickles. And let's add some spices as well. And here we'll add ketchup, mustard, and mayonnaise as our condiments. All right. Now, so we have implemented, not everything is implemented. You can see our code is complaining that we need to implement build as well. So after doing all these things, we'll just return this burger that we have created, right? So this burger builder method has multiple public methods. It will set bun, set patty, set toppings, set condiments, and at the end it will return. You have to create these methods in order, or you can skip, or you can change the order, or anything you can do it, right? It doesn't matter. Only thing is we have implemented this iBurger builder. This is the rule set of building a burger, and we are using this to make sure that our uh, bun or other burger is built as we want. So now we have the director class. In this case, it can be a waiter, right? So our waiter makes use of that burger builder and try to create a bun, right, or a burger, right? So here we are using dependency injection, which we discussed in the previous video. We are injecting this iBurger builder because waiter don't know how to build a burger, right? Waiter only serves it, right? So burger is built by a cook, or in this case, the burger builder is building the burger, not the waiter. So that is why waiter needs to inject the burger builder as a dependency to his class. So now let's continue. Let's have a construct method, public method here, and let's try to set the bun. Next set the patty. Next set toppings. Next set the condiments. And next return the built burger. So it is that simple. So now you have the, so you can, as I mentioned, change the order of this. Doesn't matter in a burger, but in a different scenario, maybe in a enterprise application, changing the order may lead to different outcomes, right? You can skip toppings, maybe you don't have to always set toppings, things like that you can do it, right? And when we try to implement it here, same as uh, earlier dependency injection, we will have to create an instance from deluxe burger builder, but with the type of iBurger builder interface, because we need to inject this builder to the concrete class. So now we have waiter. When we create a new waiter, we need to inject this builder to this waiter, right? Because waiter don't know how to build a burger. Only the builder knows how to do it. That is why we are injecting it using dependency injection. Now let's ask the waiter for our burger. That's it. Now we can display, right? Now we can display it, whatever the burger that we have received from our waiter. Right? Let's try to run it. So yeah, we can see that bun is a sesame seed bun and patty is beef patty. toppings are lettuce, tomato, onion, pickles, and these are the condiments: ketchup, mustard, and mayonnaise. Right? So if you have a different kind of a burger, you need to create a different uh, class. Maybe you can call it some other type of a burger builder, right? So after creating that, you can change these properties. That burger might not use sesame seed bun; it will use some other bun, right? It will not use beef; it will maybe use chicken, right? So if you want a different burger, you have to create a different class, but you will have to implement iBurger Builder interface. Otherwise, you will not know how to build a burger. So this is the builder design pattern, basically. Um, so it is, as I mentioned, a way of iteratively constructing a complex object step by step. And we have also separated the object creation process from our code so that we don't have to worry about how it is doing it, right? So as I mentioned, builder allows the construction of complex objects step by step, and again isolates the code from the details of object construction. So as I mentioned, so if you want a different kind of a burger, you will have to create different builder classes for different object types. And also it may require clients to interact with the director, which might not be needed in simple cases, right? So you have to interact with the waiter in this case, right? Otherwise you will not be able to do whatever the thing that you want to do. So main hazard of this design pattern is that it needs to create separate builder for each type of desired product, right? So depending on if you want like 10 different kinds of burgers, you will have to create 10 different classes or 10 different builders to accomplish that, right? But anyway, it solves the problem of creating an object step by step, which could be the solution to your problem that you are having in your application, right? So that is builder design pattern.